electrolysis. So sometimes the concentration of ion is not the part that we are going to speak about, but it is it's better I mention it or I elaborate a little bit so that you understand before we proceed. So you will understand that for the case of copper ions and hydrogen ions, they are all the positive charged particles, and we agree that they are all migrating to the cathode, but one of them will be preferentially discharged and the other will not be allowed to be discharged. One of them will be preferentially discharged, but the other will not be preferentially discharged. So what it means, let's come back to the factors for the preferential discharge of ions during electrolysis. I think you remember that the ion that is lower in electrochemical series is the one that will be preferentially discharged during electrolysis. Let me repeat this so that you understand. Narudia tena ili unielewe vizuri mwanafunzi ambaye unanifuatisha. Copper ions and hydrogen ions, they are all positive charged and they will all migrate to the cathode. But after reaching at the cathode, one ion will be preferentially discharged. Ambaye ni nani? It's copper ions. These copper ions will be preferentially discharged just because it is lower in electrochemical series than hydrogen. I think the other time I will let you know that electrochemical series that we always start with potassium and it goes down, but you will understand that the copper, it is below hydrogen in electrochemical series. So the ion that is lower in electrochemical series will be preferentially discharged. So if that is the case, it's very simple. Between copper and hydrogen, copper will be preferentially discharged. If it is preferentially discharged, so what next? It is for the case of anode. So for the case of anode, I want you to understand me well. Sulfate ion and hydrogen hydroxyl ion. The sulfate ion and the hydroxyl ion, they will migrate to the anode. But after reaching to the anode, it was supposed for hydroxyl ions to be discharged as compared to sulfate. Why? Because hydroxyl ion, it is below sulfate ion in electrochemical series of nonmetals, of radicals of these radicals. So you will understand that the hydroxyl ion, it is lower in electrochemical series as compared to the sulfate ion. So this one is supposed to be preferentially discharged as compared to this one. If that is the case, then if this one was supposed to be discharged, then it is easy. And this is, it happens to some students. They tend to say that hydroxyl ion will be preferentially discharged, and they write at the anodic reaction like the OH that is discharged to give the water and oxygen gas. But that one, it is very wrong. It's very wrong. That's why we are here in this session to let you know that you need to understand hiyo maswali kama haya ili uweze kuelewa kwamba wapi swali kuna kitu ambacho umetegwa na unatakiwa kukitegua uweze kuelewa kwamba okay, why huyu hajawa preferentially discharged. So utagundua hydroxyl ion alikuwa anapaswa kuwa discharged kwa sababu yuko lower in electrochemical series. Sasa cha ajabu ni kwamba, what is surprise, OH will not be discharged. Unaweza ukafikiria okay, labda sulfate atakuwa discharged. The answer, it is still sulfate ion will not be also discharged. So what happens at the anode? You will understand that at the anode there is copper. We have said that the electrodes that we have used at the cathode, we have the copper cathode, and at the anode we have the copper anode. So since at the anode we have copper, it is not allowing sulfate or OH to proceed with a reaction at this electrode. So what is happening? This copper from the anode, it will start to dissociate. It's going to start the dissociation. So it dissociates and it gives the product that is the copper 2 ions. So for this, what I've said, I want you to understand by giving you we call them the half reaction, so that you understand the half reaction. So let's see the half reactions that occur at the cathode and the anode. So we have the half reactions that occur at cathode and anode. So I think you're going to understand it, and after this session If you will be having some questions and some suggestions, you can put your suggestions, and we will, I assure you that we will consider your suggestions. So let's see the cathodic reactions and the anionic reaction. So let's start with the cathodic reaction. So this is the cathodic reaction. This is the cathodic reaction. Here we have the anodic reaction. So we have the cathodic reaction and anodic reaction. So it's very simple. From the cathodic reaction, we've said that copper will be preferentially discharged because it's low in electrochemical series. So from the cathodic reaction, you will be having the copper that is having 2 positive charge, which is aqueous. AQ means it's aqueous, substance that has been dissolved in water. So copper that is having 2 positive charge, and we will be having 2 electrons, so that we obtain the copper that is S, which means it is solid. So the deposition of copper will be formed. And remember, this is brown in color. So you'll be having copper that's having 2 positive charge, and at the final product, at the cathode, you'll be having copper solid, that is the deposition of copper at the cathode. But from the anode, we have said no sulfate ions or hydroxyl ion will be preferentially discharged. So what's going to be discharged at the anode? You understand that copper, it ionizing. Copper, it is dissociating. So if copper is dissociating, it means you'll be having copper that is having no charge, a copper with no charge, and that is solid. It is copper, it is in solid form, it is ionizing. It is ionizing to give what we call the copper with 2 positive charge. So this is the cathodic reaction that occurs at the cathode and at the anode.